Sandra promised to take the notes for the.
Who is?
Sam.
Oh. Hey, do we have another?
No, not yet. I was planning to ask something helping.
We can do that now.
Peter volunteered him.
Anyone interested in additional jobs? Thank you for taking that.
You were saying it's a low.
Etherpad, yes.
They volunteered. How about a JavaScript? I can do JavaScript.
Paul just wants to be a JavaScript so he can jump over the spew to the mic. I want to do last question. Oh, the jumper.
Right. Well, so far I cannot log directly connect to it.
I mean,
First blue sheet. Yeah. Has a big going. It's going. Yeah, going.
Thank you. Yeah, I made it.
Shall we start?
Sure.
All right, so let's start. I think it's past the time to start. So this is IPSECME working group, and I'm Tero Kivinen.
And David Waltmeyer.
So and I think our chair is going to be changing. David is going to be changing to be Joab quite soon, right?
Indeed.
Right.
Better looking chair. That's right.
Okay, here's the note. Well, I think everybody has noted this already, so no need to go there that much. So we have a blue sheet somewhere. We have only one blue sheet going around. So if it's a stop somewhere, wave it up and then people can actually. It's coming for on the other side now. We have one note taker also already. Anybody would be willing to do the other? If you're doing Etherpad, so you can actually just fill in stuff. And actually, it's a very good thing to go there yourself after you have asked questions. You can go fix that, you know, what you actually asked and who you are, because that's quite often very hard. And so when you are going to mic, please say your name so a note taker will know. And Paul promised to be a chopper scribe, so he can jump the queue by adding some questions. Yeah, so anybody else to be a second note taker? Dan? No? All right. Oh, I think we can manage with one. All right. And if anybody complains that this room is cold, it's not. That room was a little bit more colder than this. But we had the blankets. AMS blankets helped us. All right, so here's an agenda. So we are doing the bashing now, and then the logistic and so on. So any comments on this agenda? Anybody wants to change anything? I guess not. So then we go. First have a draft status, and then we have some work items and some other presentations. Some of the other presentations actually are something that might be in the work items also, but they just a little bit arbitrary the split there. So the first one is the working group status report. So we have already published one of the RFCs. This split DNS was published as an RFC. That actually happened before the previous meeting, I think. And we have one document, implicit IV, that is in RFC editor queue now. We have requested publication for quantum rest and IETF 2 stuff. I don't know when it's going to be in telechat or when it's going to be forward, but okay. We have finished working group last call, very long one, for IPv4, IPv6 codes, and I think it should be ready for publication. We are getting ready for we need to have a separate write-up, and then we can post that forward. We have two documents that I think are, oh, actually, one document that is quite ready, I think, the IQ version intermediate should be quite ready for working group last call and so on. For the labeled IPsec, I heard there still has been some complications going back and forth and back again with different design criteria. I think it's mostly because we don't know what kind of uses for it is going to be. So it's very hard to design a protocol when you don't know how to do it. And then we have 3 new documents that was adopted as a working group draft. So we have this IP traffic flow security, and then we have hybrid USKA, and then GI version 2. Those are still, I think they should be quite ready for also, most of them actually to working group last call. All right, let's go next one. And then we have, here's our work items. So we have hybrid USKA interrupt stuff. So then we have IP traffic flow security, and then we have a labeled IPsec. Those are the work items, and then we have other presentations in the end. So I think that's all we have for that. So we start with the first presentation with Valerie, with interrupt stuff.
So Daniel Migo Eriksson, the last draft is mentioned, not posted yet. It is.
Excuse me? So
previous slide, there is my draft saying not posted yet, and it's
posted. Okay. Okay. Good. All right.
Hello. A very small information message for the interrupt event that we had on November the 7th, testing hybrid quantum safe key exchange. It was organized by SecurNet, and there were 3 active participants with running code. It was first it's Trans1, then Quasimodo, and Elvis+. And we tested, all implementation have implemented IC intermediate draft, and one implementation fully supported QSKE, the latest version, and 2 implementations support it partially, but instead support a real post-quantum key exchange methods. So, question? No? Stefan, no? Okay, so the results. We achieved interoperability with hybrid exchange, but using only classical method between LS+ and Trans1. And Quasimodo and Trans1 also performed some post-quantum key exchange method, but the assay wasn't, the key exchange was successful, the assay wasn't established because of some bugs in ICO's computation. Well, and we also had some discussion about all this stuff. And so the conclusion, first conclusion is that it works. So hybrid key exchange works. And implementers badly need stable code points. We spent quite a lot of time recompiling our code because we had 2 sets of temporary code points, compatible, of course. So I think that, at least for IC intermediate, and I think that the draft is old enough. So I've just, a few minutes ago, I requested an early code point assignment. So we are waiting for Tara as our IANA expert.
Actually, I haven't received the request yet from IANA.
It was done 2 minutes ago. Check your email. Well, and there was some discussion too, and a few vendors expressed desire to implement hybrid key exchange once the specification is stable enough. So I think that many people want RFC and want the RFC pretty quickly. So that's all. Any questions?
Hi, Sean Turner. Do you plan to submit this implementation report to the implementation report repository that the ISG maintains?
What? Pardon?
So there's an ISG, there's an implementation report. You used to use it back in the day to progress things from like PS to Internet Standard. I don't know you need to do that anymore, but it's a place where you wrote down all the things you tested, the names of the implementations, and you kind of put it up there. That's another place to kind of like advertise the fact that you did get interoperability. So it's maybe something to consider.
Okay.
Hi, Jonathan Hamill. Did you test child rekey with the?
No, because Key was implemented only in one implementation, so we doesn't have enough participants to test against. Only initial, I can say, setup with multiple key exchanges, with hybrid key exchanges. No Rekey yet.
Is there a plan to do so?
Well, we have some discussion with Trans1, because Trans1, well, Elvis Plus has implemented it, the draft completely. But other vendors have some, well, Trans1 mostly, they implemented to the quite, well, not completely, but quite a lot. They have some concerns about how rekeying is specified in the specification. So we had some discussion. They think that they probably will think a little bit, and if we get rid of nonces and use a dedicated exchange type for follow-up rekeying, they will probably, it is okay with them. So I will check with my co-authors, because, we had some discussion with co-authors before IETF meeting, but we decided to postpone any change because the draft was in the adoption state, and we didn't want to confuse people who read the draft with some latest changes or new versions. You know, that once the draft is adopted, I think that I think that there's no objection, and there is a consensus among co-authors that a new dedicated exchange type is better than using information exchange. So it will definitely be done. And I think I will check again with Scott and with some cryptographers, so whether we can get rid of additional nonsenses on these exchanges. I thought it would simplify that to use nonsense from initial exchange. Well, after that, I think the Trans1 agrees that it's a way to go. If anyone, well, I think the draft must be discussed on the list, so I solicit any review and discussion, because it was not very many comments on the draft, unfortunately. So most discussion had among the co-authors. So just if you have some opinion, please bring to the list.
Right, and to that point, it would be useful to post the feedback that you were just talking about to the
Okay,
list.
okay, I will.
Yeah,
okay.
Great, thanks.
All right, so then we go to the next presentation, which was, let me see. That was the IP traffic flow security, yes.
I missed this in the last presentation. Did the early allocation of code points, was that raised? Yeah, okay, sorry. All right, so now to me. This is an update. We did the adoption call and recently for this draft. We also, during that same time, we also had some suggested new charter text, because we need to do that to officially adopt the work. So that the text seemed to be okay with everybody, and the adoption call was issued to sort of reduce the amount of process time overhead, right? So just run it in parallel and make them contingent. That's what the star is about. Anyway, we had good support, and yeah, so past the adoption call, we did get some comments. So that's what this presentation is going to be, is covering those comments. So one set of comments we got was that it was a good starting point. Would like to see more analysis on fragmentation. We're actively doing that right now. So hoping to have something before the next IETF, you know, so some analysis on that. I've coded this with it, you know, even with an option to turn fragmentation on and off, you know, in configuration. So, there's real, we plan to do this analysis. There's also some static analysis we can do just based on, what kind of line utilization based on IMIX, if we're having to pad out and rather than split across payloads. Has the effective congestion control on the tunnel with CC traffic? I talked to David Black, and I also went to a side meeting this time where the idea of whether there's any sort of feedback loops or oscillations when you have congestion controlled traffic, i.e. TCP, inside a congestion controlled tunnel. I believe we're okay. David, he's very cautious and he wants, us to think about it. I think we're okay because the whole point of this tunnel is to decouple the offered load from the tunnel, right? Like that's where the leakage goes, is if your traffic rates change based on the offered load. Anyway, we need to at least show that we thought about it. There is a common case of this, right, which is OpenVPN or something, right, where you're running a tunnel in TCP, where your tunnel is TCP and the traffic inside is TCP. That case is not as decoupled as ours. So it's not deadly, but I don't know how good the OpenVPN case is. So whatever. We don't like OpenVPN here. Also, be aware of how this aligns with QUIC. When I first read this, I thought it was talking about packet alignments, and a colleague of mine, Lou Berger, mentioned, no, that's probably not what they meant. They probably meant pay more, just pay attention to what's going on in QUIC to make sure that, I don't know. So I would like some clarification on what that was particularly about moving forward. Okay, so the next comment was a good starting point. And it was IP number allocation was scary. This was from Paul, but there was a misunderstanding. Paul thought we were actually trying to replace ESP, so we were trying to allocate a whole new IP payload. That isn't the case. It's just the scope of the ESP payload type is the IP number, right? So we need a new number for that to say that the inner payload is not IPv4, it's not IPv6. It's this TFS payload, right? But even given that, right, there's not, it is a small set of numbers, but we think this is a manageable issue because we reserve the first bits of our header as reserved, and if IPSEC, if we needed to, if IPSEC needed to reuse the format, we could reuse the number by just taking another bit from the first byte of the header. The final comment was that this has, this is good and that it has potential for addressing the path MTU issues with traditional IPsec tunnels. That is in fact the case. If you use the TFS header, you don't actually have, and we've written the draft in a way such that you don't actually have to send things at a constant rate. You could send them on demand if you want, right? There's nothing that requires the constant rate send. So so basically, if you were just to send these TFS payloads on demand, you don't get much security and traffic analysis, but you do get the ability to, the MTU doesn't matter. So the MTU is whatever you set to your tunnel to be. And the payloads can be larger than that because they can fragment across. So what do we have? What do we updated? We've what are we looking to update? We're looking at interpacket alignment. When you have aggregated packets inside a payload. Coding this personally, looking at some white box code and stuff. There's a lot of assumptions about header alignment. Because typically device drivers will move in 2 bytes so that the IP header is, 32-bit aligned, right? And then based on that fact, a lot of code is written so that when it looks up a length, it's just grabbing it as a UN16, which of course is going to cause an exception on the processor if that's odd byte aligned. So, I don't know if we should be changing wire formats to compensate for, questionable code practices, but, it's worth thinking about. ASICs don't care about this, right? I mean, ASICs, they don't care. So that's something that it's an open issue to think about. And then the only other thing is that we are planning to open source this. Is we want to get the a full implementation written, including the congestion control and an IKE implementation. And then as soon as that's done, which should be in 2020, we're hoping early 2020, we'll push this out. And we're totally open to collaborating and doing interoperability testing with folks.
Valery Smyslov, LS Plus. First question, you seem to leave out transport mode at all. Is there any reason? So you support only tunnel mode assays and not a transport mode.
Are you saying we only do tunnel?
Yes.
Yeah.
Why?
Because the transport mode is reusing the offered load header,
Yes.
right? We need to actually be encapsulating that so that we can pad it out and shrink it and grow it, and so it's always fixed constant size.
Well, my question is, don't you see a use case for traffic flow confidentiality for transport mode? So you seem that it is not important mode to support?
So we have a sort of this sort of analogy to like security modes, where we have, if you think about them like a knob, right, like of how secure things are, right? Transport mode is like the least secure, right? And then because you're giving away the source and destination, then you like turn the knob to like 1, right? And that's tunnel mode, where now at least you're hiding the source and destination. And then you start talking about traffic analysis, right? So then you turn mode to 2. So it was seen, it's not, you're already giving away so much information by using transport mode. Why even worry about like analysis based on, you don't need to analyze traffic.
I'm not so sure, but probably. Well, my second question, you want to allocate a new IP protocol number just to use, to distinguish IPTFS ESP from the usual TSP. So is it used only on ESP trailer as an X protocol?
Yeah, exactly. The next
yes, but it will an official IP protocol number. So you need. It's quite.
Right. That's why we called it out. It's not like we can just walk to IANA and say, give us a number, and they go, it's first come first serve. The space is small, but we have a justification. It's a major application.
But do you really need it? Because from your draft, your ESPSA is dedicated to IPTFS. You can't mix normal tunnel assay and IPTFS ESPSA. So it's probably, you don't need an IP protocol number just to know that this ESPSA is only IPTFS related.
Yeah, correct. It's the scope. I mean, that's how the next header field is defined in ESP. It's probably honestly easier to get an IP number than it would be to go back and create a new registry for ESP.
Probably, I don't know. It's a question because IP number is
well, we can look at this going forward, right? Yeah, I mean, I don't think it'll be that hard to actually. There are a lot of IP numbers available. We're not looking for a slew of them, and we can reuse the one we get. Right?
Okay, thank you.
Yeah, in fact, to do an ESP registry going forward, we could even be saying, oh, we can reuse this number you're going to give us, right?
Ben Kaduk, I guess I have 2 points now. So, I mean, I think an IP number is like kind of a big deal. We do inside the ISG say, hey guys, we got this draft that wants to allocate an IP protocol number, and like it's kind of something that could be a big deal in terms of, people think it's.
Yeah, we are aware it's not a small ask.
Yeah,
but, we think we can justify it.
Right. So I'll give people the heads up. And then the other one was relating to the alignment question, which I have to apologize for having not read the draft. But I think the sort of general sense I get from the general around the IETF as a whole is that, like, if we have to be adding new protocol machinery to our stuff to like add a variable length padding just so we can get alignment. Like there's not a whole lot of desire to be able to do that. But if it's just a matter of, well, do we have an octet of padding in here so that all of the fields have the same alignment, and it's not like I have one field that's aligned with one set and even, and another field that's aligned to odd, and like screw you implementers. Like if we can just make it something very simple.
Yeah, I think it would
constant.
literally just replicate what's already there, which is 32-bit alignment on the headers. That's the only thing I think we should think about.
I think that's a reasonable thing to consider, but we don't have to do it if we need the extra space.
Thanks.
Document SSH. For the protocol number, as we need it only in the ESP trailer, we can actually, there's a couple of ways to do without it. One of the things is that we can, I think there's protocol number 0, which is used for all kind of weird purposes, meaning no protocol number. We actually use it in the IETF. We say that there is no protocol number, it's any. and when we negotiate, protocol number, if the protocol number is 0, it means that there is no protocol number. It's any protocol is okay. And I think IPv6 uses it for some similar uses where it's actually never in the real, protocol field, but it's used for internal purposes. So we could just say, okay, we don't have any real protocol number there because there actually is multiple packets inside. And then you can have the real protocol number is because you have a header there which have the length of the payload, and you have to have, each packet inside has to have a, real protocol number anyway. So you could have, just, you don't need to have anything in the trailer. The other option is to use wrapped ESP, which is, we have a protocol number already for ESP, for the wrapped ESP, which is ESP with 4-octet extra header in the ESP before the payload, which tells that is the packet encrypted, how long the trailer is, how long the header is, and so on. And there's a couple of reserved bits which we could just use one bit and say, oh, this is packet that has multiple packets inside, so the format is going to be different.
Okay.
And of course, the third option is to say that, okay, because we always negotiate this use of this in IETF, we can always say that for this essay, the traffic is always going to be this kind of, multiplex traffic, which means that we actually just can, say that, okay, the protocol number, if the final protocol number is ignored because it doesn't have any meaning, because there's, we have to anyway go through the protocol number is usually mean for checking the policy and so on. And here we actually have to do policy checking for each payload. We are not caring about the, up layer stuff. So,
okay, thank you. Yeah, I mean, but we definitely, need to go around once before we ask for it, but yeah.
Michael, I just want a clarifying question, Taro. If we used wrapped ESP, that would be the protocol number of the outer thing, or the next header within the ESP?
I would keep that as if we put that one, I would put that as an outer. So the real IP header there would have a wrapped ESP, and it will have actually the the extra header of the wrapped ESP header. There's 4 bytes of header in there. So that would actually have a bit saying that we can actually reserve one more bit there saying that now there's 3 bits used and 4 bits, or actually I think 4 used and 4 left. So we can just put one reserved bit to say that, oh, this is this traffic flow, configuration flow.
Right. Correct me if I'm wrong and rusty, but when we do ESP over UDP, the outer IP header says UDP, and we know it's ESP only because we negotiated the port number in IETF. So we wouldn't actually be able to put wrapped ESP there. We don't.
So I'd like to make a suggestion.
So wrapped ESP RFC actually has this. It actually defines how to do that in UDP and outsourcing. What it does, it actually used one of the magic SPI numbers. So instead of having all zeros like you have IETF traffic, or you have a real SPI number, it has, I think, SPI number 2 means that, oh, it's a wrapped ESP and the next 4 bytes is the header. So it actually that's actually one of the things I was thinking about wrapped ESP is that because it already supports, UDP encapsulation and so on, because it was working with that. Of course, I don't know if anybody actually has implemented wrapped ESP, so that might be a bad, reason not to use it because.
Yeah, well, so I mentioned earlier coming up that so first of all, IPsec is a pretty big deal, right? So we shouldn't necessarily be so scared about asking for a single IP number, and also we do have the ability to once we get the charter text in and we have an official working group document, we are allowed to ask for early allocation. So we can float a trial balloon here, right? I mean, we're able to go once it's a working group document and ask IANA for early allocation, and part of that early allocation can be an IP number. So that can,
we need to move on.
So I just want to say that I'm supportive of what you just said, and I'm also really supportive of making good use of the wrapped ESP allocation, which I think has gone to waste.
So the consensus I'm hearing in the room is that we should at least investigate some options before we make the allocation request. Tiro, maybe it would be useful if you could send some examples to the list. Being a chair that's stepping down, I can assign work and then not.
Yeah, that's awesome.
The consequence. But it would actually, I think, be useful for that.
Okay, thank you.
Thank you.
The next presentation is labeled IPsec, which has also some kind of back and forth stuff.
Okay, the next slide.
Oh, you do that yourself?
Let's see.
We offloaded.
Stone Age. Okay. So just a quick reminder, one slide. This is an example SPD entry that shows the security label. This is the one we want to put in the traffic selectors for the system. And the question is how to convey this information between two IKE points, two IKE endpoints. So this was the very original proposal from Sahana and me. We decided to just use this is actually the second proposal already. No, okay, sorry, no, this is the first proposal. It's a TS type, it's a traffic selector type where we just put in the security label and the length, and it was very simple, and it was a new traffic selector in addition to the existing ones. And then problems came up because people said, well, this really changes the core RFC and how we select these traffic selector types. So then Tiro came up with a brilliant idea like, oh, let's just merge them into new traffic selectors. So instead of adding one new one, we'll add one new one for IPv4 and one new one for IPv6. And if there's ever a new type of traffic selector, we'll add one more type. So you would basically copy all the traffic selector types we have, but add ones with and without the security label. And so some people liked it, some people didn't, and that changed over time as well. So the question really is like how can we best move this forward? Because like everybody has now changed their opinion, except I think Valerie, who's always hated all the options. So how does this negotiation really happen, and do we really need a traffic selector? So one of the issues is also with the narrowing you can do. If someone requests something and puts in a traffic selector of a security label, and then the other end either doesn't support it or the other end doesn't want to use it, they will return a narrowed down proposal without the traffic selector. But they have installed the SA, and now the other end might have to say, oh, actually, I really didn't like this. So the initiator then goes like, oh, I don't like this narrowed set, so now I have to send a delete, and then try without the label and maybe see if they like that. Or like, so it really complicates how this negotiation is done. And then we got thinking, well, we could send a notify to at least say, hey, we'd like to use this security label. And then, of course, the next question quickly became, well, if we're sending a notify, we might as well put the label in the notify and not use a traffic selector and avoid all these issues. Because we also did a quick check on the code bases that we could look at. Do people actually properly narrow down traffic selectors? So if you see an unknown one, do you actually just drop it from the set and continue to negotiate the SA without that traffic selector type? And the answer is, I haven't seen a single implementation that does this. They all return an error, like I don't know this error. So the question remains how to do this. So I am now back to thinking that notifies would actually be easier and better than traffic selector types. So the question is, what do other people think? Because it's hard to see what people like because it has been changing quite a lot.
Valery Smyslov for this plus. I think that a second bullet is definitely not an option because it's traffic selectors, individual selectors and traffic selectors are interpreted as a logical OR, so that if you new TS type that will express only security label, you cannot combine this.
Right. So
either a new notify payload or a new which is V4 plus sec label, V6 plus sec label, and I think that the third option is most I don't know, right from formal point of view, from not from practical but from theoretical point of view, but from practical point of view, I agree that it leads to explosion of traffic selector. You just copy all the current selectors that are two types, the V4 and V6, and add them security label. And if you later want to add something else, we need to multiply it. But so probably new notify payload is some kind of compromise in this situation. I think that it's probably a way to go.
Hujin for Nokia. I think I don't like the third one because the notify implies that you bind this security label to a particular tunnel. But my use case to bind the security label to actually child, so more granular than a tunnel.
Sorry, I didn't fully hear you. To tie the label, the security label to.
So if you have this as a third operation, basically you have a notify, right? Notify essentially means that you tie this label to a tunnel, not a child SA.
No, you can actually, if you think of the use transport and use compress notifies, they also are specific for a child SA, not for an IC SA. So this notify would also be specific for the child SA.
Okay, so when you do like a create child SA, you can include this notify?
Correct. Yeah, if you do create child SA, you would also send to notify.
Okay, so I get that works then, because for me, I think it's really should bind to a child SA, not in the tunnel level.
Correct. Yeah, they must bind to a child SA.
Michael Richardson. So I'm going to say that I haven't formed an opinion as to which is the best choice here, but my opinion would be formed by considering two things, and I have a question as a result, which is how would an implementation which doesn't implement labeling respond to these three things? And that leads to my question, which is it useful for, except in a transition upgrade period, is it useful, or do you expect that an endpoint desiring security labels will negotiate with endpoints that don't have them and don't implement them, and expect to just create an SA that doesn't have labels and just proceed along as if with that?
So to answer that, I don't for the security labels that I need this to work for, this will not be the case. So if they did not get a confirmation of the notify in the reply, they would consider this a failure.
A failure, and they wouldn't set up any tunnel.
Correct.
Right. So then I would say that it really doesn't matter that much, because the end requesting the label is going to have to deal with whatever failure comes back, as opposed to saying, oh, you picked the TS without the label, I'll go that way then, if you like. Okay, and all I can see the situation where you might upgrade things incrementally, and you want to turn on the policy, and as soon as it's all there, everyone's happy. I don't know if your use case really supports that scenario. I think you turn it on the whole network. Once the network's ready, you go to label, and until then, the network's not labeled, right?
Right. Yes.
Yeah. That's what I think is the case. It's not like, other things where you want to go, oh, let's go to AES 256 next week, but 128 will be good enough for the next week, right? It's okay, right? We still want to transmit. So that's my take on it. Is what will be easier for you to determine if the other end doesn't agree, and pick that.
Right, but do take into account that, so I have a very specific use of the security label. Other people might have other uses for the security label where they might decide that something incremental is valid for a certain period of time. So it's not a use case we should discard just because I don't need it.
I think you should probably, unless those people are quite loud, I think you should just go ahead with what suits you.
I think actually, if we actually use the new traffic selector type, that allows both of these, because one of the things if you only allow connection with security label, both cases in the cases if you have if you propose something that normal IPv4 and IPv4 plus security label, that gives an option for the other end to pick which one of, and then you are allowing that for your policy. If you only propose IPv4 plus sec label, that means that you only allow that in your policy, and that will actually be better for you, because the other one will immediately fail that if he doesn't support sec labels, because he doesn't have any traffic selector. It would say traffic selector unavailable or unacceptable, I think. So that way actually gives you immediate error, instead of you getting back essay that you have to immediately delete because it didn't have the notify. I write this like this kind of explicit, cases where you actually you can propose either with the traffic selector, with sec label, or without, or both, and the other end can decide what you propose. It tells what you want, and what the other one responds, it tells what he wants. And there is, either get an error or you get an essay that you can use. With notifies, the problem is that we don't get that one.
So you're advertising for the third option still?
Yeah, the one that we saw, IPv4 plus sec label. And I don't think we are going to be adding that many of those new things in the sec label. The other thing we had earlier discussion was how the sec label is going to be used. How is it string, is it number, or is it something like that? Can it be narrowed down? And that's something that we need to decide. And that's actually one of the things also that affect these things, because it affects how it's encoded.
But all the narrowing can be done. Like, you can have a whole complicated Turing machine inside your security label if you really want that. Like, that's all up for everybody else to define. Like, you just send it over the network.
So that's why actually I think it might be what the current draft I think says is that the security label is just one label. There's no range there, and you can't narrow it. You have to accept it completely right.
But that doesn't mean that you cannot accept everything that starts with the letter A.
Yeah, but you have to return whatever the other one said.
It just means something else, and whatever it means is outside of the IC implementation.
Yeah, that's possible. Yes, that's true. But you still return actually the whole thing.
Right.
You can't truncate it. It's the same thing with the like we have in the protocol field. You have to accept. If the protocol field is anything else than 0, you have to accept that exact protocol number. You can't do anything else. Yeah.
I'm gonna have to cut the line. You're good.
So Ben Kaduk, you have notes on Jabber that the notify payload could be better because nobody has ever really defined new traffic selector types, and we know that implementations can handle unknown notification types, but they might choke on unknown traffic selector types.
Right, that's true.
I'm just wondering where this label is going to be. Are you going to put it into the SPD?
So can you speak into the mic?
Where are you going to? Yeah, I'm not speaking in the mic.
No. Then they asked you for your name.
Oh, my name, Daniel Migo Eriksson. So I'm wondering how this label is going to be used. Is it expected to be placed into the SAD?
This is actually the output of the Linux access for RAM policy database.
Okay.
So it's actually it's a real traffic selector. So if you send a packet with the source destination address, but it's not labeled with that label, it will not match.
Okay. Thanks.
So it sounds like the third option is probably the one to look at. Are there any concerns with?
Well, that's not what I got from this discussion. I got from the discussion that in theory the third option is nicest, but in practice the first option is nicest.
So if we go with the first option, is there anyone that has any concern with that approach?
who is responsible for this path. I think that it must be discussed on the list, because I think that there are not many people here to decide right now. Okay.
That are given in. I think the bad idea about the bad thing about the notifiers is that you get an essay created even if you don't want it, and you have to delete it. And there's all kind of race conditions because yeah, I have an essay up, I have a traffic going out. Oh, no, I can't use that essay. Even if it's created, I need to delete it immediately, but I can't delete it before I get a response back. And you have to manually block, things so that doesn't leak out in the essay that is not allowing it. Right. And another thing, in all of the cases, you need to have a new code in your traffic selector, code if you are going to be implementing. I mean, everybody who is going to implement label security are going to be modifying their code anyway. So adding the code for traffic selector support there is to be smart is something that you should be doing anyway. And you shouldn't be proposing these to anybody who is not really. In most of the cases, you don't propose these to anybody who doesn't agree earlier in your. You usually put in the policy to say, "Oh, for this I propose these labels."
So I'm not hearing that there's enough consensus around an option. So maybe we need to take this to the list and weigh options 1 and 3 a little bit more. Could you drive some discussion on the list for that?
Sure, I can try, but we've been going around in circles for a bit, so I don't know how to steer this to an end.
Yeah, so I mean, my suggestion, I thought I kind of agree with what Paul said, was like 3 is like what you would do if you were going to like do it super correct, but in the reality of the world, the practicality option 1 is to do it. And I agree that we have to take it to the list, but like maybe we could do a hum on that and then confirm it on the list.
And the hum you're asking for is?
Well, option 1.
Okay, so if you,
I don't care what the answer is. I just want to hope you get it done.
One of the things that the problem with option 1 is also that we don't have that in any of the drafts. So I would actually propose that we postpone that hum until it's actually written somewhere what the notifier is going to be looking like and how to behave when you receive or send it.
May I suggest, well, that's a good idea. May I suggest that you simply ask for a hum of objectors, right? If you don't understand it, you probably shouldn't object.
So,
right?
All right, how about we do it this way? So do you understand, if you understand what we're asking for in option 1, please hum. It's pretty weak. If you have any concerns with option 1, please hum. That's weaker. Definitely weaker. So it sounds like maybe what we should do is write up an example of what option 1 would look like, and then we can consider that. Okay. Thanks. I think you're up next. Did we?
The next one is, no, it's Vapen. Yeah. So the next one is traffic sector payloads and SA stuff. Yeah.
Hello, everyone. My name is Wei Pan from Huawei. Today, I'm going to talk about the updates of our IK version 2 Rakin optimization draft. Doesn't work?
Maybe I have to.
Yeah, you have to.
Yeah. How about now?
Okay. First is a quick recap. Our purpose is to optimize unnecessary payloads at Rakin essays, including to omit SA payloads at Rakin IK essays and to omit SA and TS payloads at Rakin child essays. Why we can do that is because configurations may not change frequently, and the SA and TS payloads at Rakin essays will be the same and as the ones at creating essays. So as the payloads are the same, so we can just use the previous SA and TS payloads instead of sending them again at Rakin. Why we want to do this is because repeatedly sending SA and TS payloads is a redundant operation, and it unnecessarily consumes resources such as bandwidth and CPU. And the rekeying happen periodically, so this will mean periodic redundancies and burdens, especially for the constrained devices. And for the IPsec assays, when you set the lifetime based on the transported traffic, and as you know, the bandwidth now is increasing, so the rekeying interval will become shorter. So the rekeying happens will become more frequently, and maybe even less than 20 minutes in some products. And in 5G networks, there will be more than 100,000 IPsec terminals will be established in one local network. So the situations will become severer. And so some of our products have already implemented this optimization. And next is updates of our draft. Based according to the opinions last meeting, we make the draft, the optimization simpler. So first, we make the IKE-SA rekeying optimization and the child SA rekeying optimization optional. It means that it's up to the implementer to optimize IKE-SA's rekeying or just child SA rekeying, or both these cases. And if you don't think IKE-SA rekeying optimization is essential, you can just don't optimize it. And for the optimization processes, we also simplified it. And before, there are 3 subcases, and now we discarded the third one, and the rest remain 2 subcases are: first is the initiator sends the optimized rekeying request, and the responder can accept it or just reject it. Finally, here is the whole overview of our whole solution. First is the negotiate of the support of this optimization between the initiator and the responder by sending the new notification at IKE auth message exchange. After negotiation, there are 2 optional implementation: is the optimizing the IKE-SA rekeying and optimizing the child SA rekeyings. And for each cases, they are all both contains 2 subcases, and as I just described it before. So this is a whole overview. About the future plan, we want more feedbacks, comments, and reviews. And as it is very simple and is useful in the 5G network, so we are looking for working group adoption. And question?
Can you go back 1 slide, because that's
okay.
Everything, right?
Oh, sorry.
So what I don't like, sorry, Paul just read that. What I don't like about this proposal is the part where the initiator can send the unchanged SA notify, saying it's doing the one without the traffic selectors, and then the responder can decide based on whatever reasons that I don't like this no proposal chosen, because now I've got a failed rekey. And I would much rather have to know beforehand whether I can do this proposal or not before doing it. So is there any reason, does your responder dynamically decide that now it can do this and maybe 5 minutes from now it cannot do this? Or do you always, or is it just a matter of like, it doesn't support it or doesn't want it, it's not configured for this connection? Because if it's purely configuration, then this should not happen. If it's based on load, then I can see why you might want to do that, and maybe I'll like it a little less. But
actually, you mean the second case, why the responder will reject this optimization is we think that for some products, we usually will, if the configuration changes on the responder side, usually the responder will initiate the rekeying process immediately. But as this is not a must in the RFC. So for some products, they may not do this immediately. They will wait for the rekeying period. When the rekeying times out, the responders just initiate the rekeying. So when in the second case, when the responder receives such optimized rekeying request, but its configuration has changed, so it wants to use a new like cryptographic suite, so it will reject the optimization. Yeah.
So that's kind of weird, right? Because now what you're saying is in the initial ICA you negotiate with these notifiers what you're willing to do, and then halfway through, without telling anyone, you decided not to follow up on that promise.
Sorry.
Take the case where, Michael here, so take the case that the initial policy on the initiator was AES 128 or AES 256, and they agreed, and the responder's configuration was 128. So they agreed, okay? Life went on. But now on the responder, they now have changed their configuration to AES 256, which would still be acceptable to the initiator, okay? So the initiator then said, oh, let's do AES 128 again, and the responder says, no, I need to do 256. So if he'd sent his whole list, both of them, then we would have picked the other one.
I understand what you're saying, but first of all of these things are not allowed. You have to use the same. In rekeying, you're not allowed to just change the entire protocol. You have to do the exact same parameters. So this is actually a bad example.
Okay. So
like you cannot actually say
me that essay that's proposed has to always be the same in a rekey.
Correct. And if you want to split this and say, I want one to show support for Ike, and I want one to support the child essay, then that's probably better, so that you can decide what you want to do. But I don't like this, like you have this configuration, and I understand you're reloading the configuration and you don't want to kill 100,000 tunnels, but you can't just like change all the parameters and accept the initiator to continue.
Valery Smyslov for this plus. Well, for ICA rekeying, I don't think that this draft gives us a lot of optimization, because if you do just usual ICA rekey and put in a SA payload just the same algorithms that are used for ICA, it will be a dozen of bytes and probably 30, 20 bytes. And you replace this 20 bytes with 8 bytes of, I don't know, notification. So it's very small win, and ICA rekey happens very seldom. So it's not, well, I don't think a big optimization. For child SA keys, it's probably a slightly different situation, because you need to put a traffic selector, and traffic selector can be quite complex and very long, and if you omit it, it will probably give you some save in size. But I think that for ICA key, it's not worth to complicate. So please think whether it's possible to simplify your draft, just omitting ICA key, probably omitting, at least omitting ICA key or something like that. For child SA keys, probably makes sense.
Yeah, I got you. Because IKSA's rekeying maybe just happens not very frequently, and but it is also an optimization, and we have implemented.
It's very small optimization, because you save just 10 bytes.
Yeah,
it's compared to hundreds of bytes of the IC message size.
So we made it optional. It's not required. Yeah.
Well, right. So thinking about this and what the discussion that just happened, isn't it just possible that this is over-engineered? Like, you can still get this optimization, but why try to make it so fancy, right? Like, just tear the essays down if you have a configuration change, right? So then you don't have to have all these different moving parts. The optimization, if it's really cheap to implement, then it's nice, right? I mean, you're talking about 83 things a second in the whole network, right? So how many chances of putting new bugs into the code do you want to optimize an 83 times a second thing? But if you make it simple, it might be easier to swallow this, right? Just simple, trim it way down, maybe.
Yeah. Okay.
Paul Wouters read it again. And I just want to say something, just like I said it last time. I do think for the child essay, it's really useful because not only are you saving a number of bytes, you also save processing all the traffic selectors because you have them already. You don't have to verify that the selectors are the same as the ones you had installed before. So actually, I really like it from the child essay because we could all use this per default to make our code easier. It's not just on some high performance server. And I think I also said it last time that I don't see as much value in the Ike version, but the child essay version, I definitely see a good case for it.
I don't like this because this has options. This adds more options that we're doing, and options are always bad because we get. If this would have been proposed when we were making the Ike version 2, we could have said in the Ike version 2, you never ever send SA payload or traffic selectors ever in the rekeys, and that would be very simple and it would solve the problem. Now I don't want to have we have to write this code and we have this, we stuff, SA unchanged, do we have to do that? And it adds new options, so that has to be tested. And that's why, we have way too many options already there. We have resumption, we have lots of things we have to text, and I don't want to have, extra thing, especially even if you say, it can happen every 20 minutes, but every 20 minutes means it happens every 4 gigabytes. We are saving 20 bytes or 30 bytes every 4 gigabytes. I think it's like wasteless effort. It actually takes more time for us to, discuss it here than we are saving the whole time of the, lifetime of this protocol project.
Yoav Neer, why are there 2 separate notifications for SA unchanged and SATS unchanged? The first is only used in phase 1 and the second is in phase 2, so there's no ambiguity. You could just have one.
So, from my understanding, there's also some IPR considerations relating to this. Do you want to comment on that?
Yeah. After last meeting, and the IPR has disclosed claimed on this draft, and I think there are many drafts, many RPCs in IETF that they have the same IPR claim, so I don't think it's very big problem for considering IPRs, and but I don't know what people will think about it.
Yeah,
From my own view, I don't think it's a big deal. Yeah.
So if we were to adopt this draft, that's one of the things that the working group would have to have some consensus on accepting. Who's read the IPR notification on this? Can I see a show of hands? Or the posting of, or the, hasn't there been the IPR disclosure?
I mean, can we just, is it the free one or is it a royalty based one?
Let me check. I think it was license required.
Yeah, so reading from the disclosure, it says reasonable and non-discriminatory license to all implementers with possible royalty free. So as you pointed out, Dave, if there's one there, that's great. The working group just has to decide that they're happy with it or not. So
I think actually most of the other IPRs we have are actually don't require you to conduct. They're usually saying that we are defensive. If you sue us, then we can use this against you. But this when you require them to to talk to the IPR owners before you can implement or use it in the code, that's actually is annoying.
So
do we also want to have harm of adopting this, or actually perfect? I need to first for the ADs wake up. So the question is that I think this might be part of our charter or might not. The question there is that because we have in the charter we have text saying that we are doing optimizations for something like that. I think it's like generic stuff. And this could be part of that, or it could be separate. So that's actually first thing we need to decide. I remember last time we were thinking about this, and I don't think we actually get an answer for ADs at that point either. And actually, what's the status of the AD, charter updates?
Ben Kadek, yeah, I have some draft new charter text that I need to put in the data tracker and kick out the review process for. So that should happen in the next week or two.
So, but you can't, you don't know if this is actually part of, would you think that this would fit in the charter, current charter?
I would be unhappy to assume that it is in the current charter. I would
okay, so you would say that we need to update the charter anyway. So before we do the working group adoption, we have to, work on the charter text anyway. Because that's actually pushes the, there's no point of doing hum to we adopt this if we are, have to do charter update anyway.
Right. I will double check today, but I think so.
Paul Wouters, we've gone back and forth about whether we should do all these minor charter updates all the time. I want to remind the chairs that this is IPSEC minor extensions, and I think this is a pretty minor extension.
I know that, but we have also in the charter text that saying that we actually I think we have text there saying that we always try to charter every single thing we actually do. We don't adopt anything that is not in charter. But anyway, but we can actually do the adoption call anyway we have to do it anyway in the working group mailing list. So there is no point of doing that. We will discuss about the chartering issues first, and then have the discussion later about this adopting this. Right. Okay, the next presentation then is the Paul again. And we are running out of time a little bit or behind the schedule, so try to be fast. I know you want to talk about that.
Sure, fine. I'll also only do this one slide. So graveyard. So we talked about doing about killing off some things. Just a reminder, we have two RFCs, one for IKE and one for IPSEC, where we sort of once in a while update all the algorithms. But then we only really obsolete the algorithms that are really bad or that are like for some reasons are like strongly discouraged. But there's a lot of these things that sort of linger around that are that we don't touch. And so the proposal here is to do a few things, kill all those old May things that we don't really use anymore, that are kind of deprecated, and then also trying to nail down another bit in the IPSEC in the IKE v1 coffin, because we really want people to not use this anymore. So the changes to the draft from 0.0 is that I was a little too aggressive. I added some things like HMAC MD5 and DH groups that I really wanted to not be used anymore, but those should go through the regular updates of the RFC 8221 and 8247 BIS documents. So I removed that from the document. I added the references to the documents in everything we do. So if it said something like, we're obsoleting this, then it instructs IANA to actually say, to clarify whether this was obsoleted or deprecated in the existing RFCs or in this new document. And I spoke to Tero a couple of days ago, so we quickly made another change, and I submitted that yesterday, is that we're actually formally asking to close those two old IKE v1 related registries so that nobody can ever do that. Now, informally, we've already acted like this for many years, that we don't add anything new there. But if we're doing an RFC, then we might as well officially close these registries.
Dan Harkins. I noticed in the draft it says, IKE v1 must not be deployed. And I'm not really sure that we can say that any more than we could say, like, you must reduce your carbon footprint, or you must not take drugs, or something like that. We don't really have the authority to. All we can say is we really don't like this, and which means deprecated, and it's already deprecated. It's been deprecated for 15 years. So unless we're going to do like the double secret probation thing, so then it's deprecated.
So we want to make sure that people really understand it, because yes, it has been deprecated. So I am happy for new text.
I agree with all the other stuff, because it says if you don't get rid of IETF1, you'll have all of these problems. That's exactly what we should say. If you don't do it, you'll have all of these problems, but we can't mandate that somebody not deploy a protocol. That's just ridiculous. And furthermore, I'm not sure if well, maybe we can close the registries, but there are other standards organizations that use the IETF1 registries. And if you look at the last update to the IETF1 registries, there's actually a new column added to one of them that says not for RFC 2409 because these entries were added for somebody else.
And at that time, we also agreed that there is going to be never ever going to add new stuff to that registry. And
Who's we? Who's we?
As a working group and ISG. And yes, we can close the registries. There is actually lots of closed registries in IANA. I was talking with IANA this earlier.
I know that there's closed registries. I'm not arguing that you cannot never close a registry. I'm saying that somebody else is using this registry.
No, this is not going to be disappear. It's going to be there. It's going to be closed, which means that it's not going to have a new allocations anymore.
I understand what you're talking about, but I'm saying if somebody else is using this registry, then they may not understand what's going on. And, maybe you want to send maybe you want to send
talk to yourself. Oh, sorry. You should talk to yourself.
Maybe you want to send we're closing this registry. Change your spec to refer to a different registry and not this one anymore because this one is dead. Right. So what happens if they want to add another curve?
They are not going to add.
If they want to add another curve, then they can't. Right.
Yes.
But what I'm saying is that if we had told them that this is happening, then they can change their.
We told them that this is going to happen.
Who did you tell?
No,
we sent a liaison. We sent an email when this was happening in IEEE. IEEE sent as a request that we need to add that. As an ISG the liaison statement was sent back, telling that this is registered that is not for this use. But IEEE answered that we can't change our document anymore because it's so late. It was bullshit because you could change it, and then because of that, ISG allowed them to allocate this number, and then IEEE said, good, we could get the number, so we don't need to change the document. They have already claimed earlier that they can't change the document, and now they said, don't need to change the document because
that sounds like that sounds like a really crazy history, and I don't believe any of it.
But so Dan, just in reply to you then, by saying it is closed, we are signaling to all the people we don't know that they shouldn't be relying on this feature anymore.
We have a liaison. We should send a liaison request to them saying, this is what we're doing. These are the implications of what we're doing. You are forewarned that this is what we're doing.
Sure, we can do that.
So am I hearing though that you're not against closing those registries? You're more talking about the notification mechanism.
Yeah, Ben Kadek, as responsible AD, is totally right. We should send a liaison before we just blindly close the registries. Also, relating to Dan's point about, we can't say you must not use this protocol. It doesn't actually have binding force. I mean, yes, that's true, but we put that in our documents all the time as IETF. And the implication is sort of, if you are adhering to this document and you're compliant to this document, then you're not using IETF1, but you can ignore this document at your own peril.
So, Daniel Migo Eriksson, it's really good Sean is behind me because we had the same kind of discussion in TLS where we said, well, why don't we deprecate TLS 1.2? And some argues that because 1.3 is obsoleting in the header, TLS 1.2, it was not necessary. So I'm not against the draft, but I just like we are coherent with other working group maybe.
So to clarify that a little bit, so in my view is when we say use IETF2 not IETF1, we are technically talking to implementers, like don't implement IETF1. Like we're not saying don't run IETF1, and this RFC is more or less saying it's been so long now, you should really also not be running this anymore.
Don't necessarily disagree with you.
Hi, this is Sean Turner. Just a minor word suggestion. I think technically what we're trying to do here is you're trying to say don't use it, but you're also trying to, obsolescence does not make the document historic. So what you really want to do is in the words, I think it was like must not, this document has been obsoleted and it must not be deployed. I think you actually want to say you want to move the draft to historic. There's a process for that. And that's really what you want to do. So you're taking it off standards track. And then the additional statement is don't deploy it. So I can send you some suggested text.
And also, we won't be doing any maintenance on it. So do you have clear guidance on on updates to make?
If we have good minutes, yes.
Sean?
So just a note, who's going to send the liaison request then? Does it come from you guys?
I think it's comes from IEEE. I think we have IEEE liaison person who is actually going to send that.
So there's a
we will initiate with the IDs.
Okay.
So I think we have 5 minutes left. Valerie, is that enough time for yours, or should we? Okay. Daniel, sorry.
I'll try to be quick. So it's an alternative approach for post-quantum pressure key in IQ2. So PPK for IQ2 are defined in the draft. It is already in publication request and state. It's just outlined. So we send, in the IKSA NEET, we negotiate that PPK is used in the next exchange, and in ICOS, the PPK is PPK identity is sent, and PPK is used is steered into the SKD and SKP computation, so that initial IKSA is not protected by PPK with PPK. So it was workgroup decision at that time. It was assumed that nothing really sensitive is exchanged in IKSA itself. So, and if and a child SA are protected, of course, and if someone needs IKSA to be protected, it will immediately initiate a rekey, IKSA rekey. So the problem is that now we have group IQ2, GIQ2 draft adopted, and in GIQ2, the session keys are immediately transferred from group key server to group members in the initial IKSA. So these keys are not protected. These keys are really sensitive information. They are not protected by post-quantum pressured key. So current GIQ2 draft suggests a very long sequence of exchanges that can work around this issue. So we first perform IKSA NEET, then we perform GSA out. GSA out is equivalent to 5 hours for GIQ2, but in GSA out we don't transfer key. Instead, we send identification key is needed. So then group members initiate IKSA rekey, initiate a registration exchange, deletes initial IKSA. So it's a total of 5 exchanges and 4 round trips. So an alternative approach would be to use IK-intermediate exchange that just becomes, well, rather popular. Not popular, but instead it is implemented by even some vendors. And to send a PPK identity in the IK-intermediate exchange. We can even send several PPK identity. That is not the case with the original approach. And in this case, the IK-hours or GSA hours exchange will be protected with PPK because we will steer PPK. We will already negotiate which PPK to use, and we will steer it into the computation for the SKD keys. So if we compare these approaches, I mean the approach of traditional approach and the alternative approach of using PPK, there are clear wins for GIQ2 case because 3 exchanges instead of 5, 1 DH computation instead of 2, 1 computation of hours exchange in case PPK is optional instead of 2, and multiple PPK can be sent, so it is possible to roll over PPK in more easy ways. And for I can say for IETF not for GIETF, just for traditional IETF, there is more mixed situation because we need 3 exchanges instead of 2. But if you use intermediates for some other purposes too, we can piggyback PPK identity into it, so it's probably not win or not lose, it's something in the middle. And it's still less complication for IOs if you need protection for IKSA. So what's the proposal? The proposal is not to replace. It's just an alternative approach that can be used. It's rather simple. It's very straightforward. So it can coexist with the traditional approach that is defined in the draft that is already in the publication request states. And for GIETF, this approach can become the primary one, not the alternative, but the primary. So what's your opinion, comments, questions, probably adoption? I think that I will ask for adoption if there is enough interest.
Yeah, we can bring that to the list, but this draft has been ready.
Close to mic, please.
So Daniel Migo Eriksson, this draft has been presented many times, and I think we can bring that to the list.
I don't think this actually. This is the alternative method.
Yes,
this is the first time it was presented, and the draft is actually
it's the first time presentation for an alternative approach.
So actually, I ask, how many has actually read the draft?
So I didn't read it.
Okay, 1. And somebody has written it, so there is 2. Oh, sorry. Actually, that doesn't imply that you have read it.
Wei Pan from Huawei. I've read this draft, and I think it's very easy to understand, and it's a good idea, I think. Yeah.
So I think it's the. I don't think everybody people will have questions here if we are haven't read it. But okay, I encourage people to read it and think about it and send their comments to the email list because we are running out of the time anyway. So,
can we get some volunteers to read the draft and provide feedback? Daniel, Paul, thank you. Yes. Can add that to the notes. All right. So Daniel, we have time if you want to come up.
About 5 minutes.
Hi. So this draft is basically explaining how introducing a method to negotiate multiple child essay at one time. So next slide. Oh, yeah. So as I mentioned before, usually the create child essay results in creating only one child essay, and what we'd like is to improve that from 1 to n. So this requires basically you propose a number and you provide another number saying I will not go above this number, and you provide some arguments so that you can generate all the necessary parameters for that. In this case, that's going to be the SPI, nonce. That's going to be used to generate the different SPIs for each child essay. And you have a response with the same parameters, but in here, the n child essay is the number agreed. Max child essay is sort of useless. It's just repeating the previous one. And SPR nonce is just a hint to derive all the different SPIs. So this is how the key maths is generated for all the different child essays. This is how you generate your different SPIs. And this is the payload exchange, and you can populate your SH.
Document SSH. I don't think you actually can do that with the SPI numbers because the SPI numbers need to be unique. And now if using hashing, there's no, of course, yes, you could generate nonces so long that you actually get all the, SPI numbers you generate are going to be unique, but it's going to be a little bit annoying. We had this feature in IETF version 1. In IETF version 1, you could actually propose multiple essays. You send, multiple SPI numbers and, create it. And I think we were the only implementers ever who implemented it, and in our case, we implemented it, but there was no way to configure it. So I think it's actually a little bit, I would really like to see first that people will actually, what is the use case for this before we actually want to implement it?
So the use case, well, one question is about the SPI, so you can extend this as long as you wish. So maybe there are other ways to do, but you can choose the nodes so that you don't have collisions. The use case is clearly when you have multiple cores, it's better to have multiple SA, at least one per core, or and to avoid that you have some context switching, and some essays that are shared between the multiple cores. So that's the main motivations.
Michael Richardson says replay counter conflict.
So I'm going to cut the line. But for those that are on the line, if you do have interest in implementing something like this, it would be interesting to hear.
Ben Kayek, so just to check, all the child essays get the same traffic selectors?
The same?
Traffic selectors.
Yeah.
Valery Smyslov, LS Plus. So please remember that there is a limitation on the length of PRF plus key material, because there is a counter and it is a one-byte counter, so you can't iterate PRF plus more than 255 times. So if you can't generate more than, well, it depends on the size of the key for the child essay that is needed, but there is some limit on the number of essays that you can generate. It's hard-coded limit in the IQ2 space because of the definition of PRF plus. And I think that, well, I agree with Tara that it's a bit complicated. So probably, well, I'm not sure that this. Well, I see that it can get some optimization if you need to do a lot of essay at the same time, to several essays at the same time. But I'm not sure it justifies the complexity. Well, we should evaluate it first.
So, so two things. So the first one about how you extend the key match.
Yes.
That's worth some review. I agree on how much you can do that. That said, the key match is then used to generate the keys.
But the length of the key match is limited.
So, but well, it's going to be basically a restriction on the, but we can work on that scheme. That's so about the complexity. I think you're referring to how the SPRs have been generated.
Yeah,
sure. But I sort of don't understand where the complexity is, because I think you can generate a nonce, and you can see if you have any collisions with your SPI. And
well, at the same time, you well, okay, it depends. You need to reserve all these SPIs.
Yeah,
and because
I mean, you want to use those that are. I mean, you say I'm going to do an exchange, so I'm taking nonce. Okay, these are free. No, there is a collision. I take another one. Okay, fine. I'm sending it, and if those the other per choose how much essay is willing to generate, does the same thing. And but when suppose he's taking less, or is not taking that exact number, or is saying no, I'm not using those multiple child essay, then I receive that, I deallocate those. So
I understand it, but
we have 2 minutes left. If you keep your comments short.
Okay, Paul Wouters, Red Hat. So I also thought about this a while ago, and so we've been talking with a few implementers. So there's 3 use cases so far that have come up where this would solve an issue. One of them is if you need to bring up many childs and you want to do PFS and you're doing Diffie-Hellmans for each one of them, it would be really expensive for some devices and problematic. I talked a bit with Tero, and he came up with a really good solution. You can do this differently by rekeying the IEC essay and then creating the child. So creating all the childs and then rekeying the IEC essay. So there's other ways where you can actually use it without PFS and still gain the PFS property on the child essay. So that was one use case. The second use case was if you do this per CPU. So we're working with a few other people with Strongs on the Linux kernel to be able to do more processing, because currently there's a limitation on CPU versus NIC receive queues, and so we cannot use the full amount of traffic. So we want to install multiple of the same essays on different CPUs. The use case there was brought up. You can actually do this on demand whenever another CPU is hit. So if you have 64 CPUs, you don't have to set up 64 children. You can just set up, as soon as a new CPU generates a packet, it will acquire a new sort of fake acquire message, and you will set up the essays on demand. So you're sort of spreading the load there as well. The third one is similar to the second one. This was for the quality of service different essays, where you were also thinking maybe you need to set up 64 essays at once. And a similar thing applies there. If you only set up the ones on demand based on the quality of service bits, you're actually not setting up many of them. You're probably only setting up 2 or 3. So then it doesn't really become much of an issue anymore. So I think this optimization is not really needed based on the use cases that I know.
So the second thing you mentioned, so the first, I don't remember the first one. The second one, I think you're saying that you can have multiple create child essay after one of the other, which means that is that correct, or?
Yes, you do this on demand. So if 2 CPUs are being used for this traffic, then you have 2 essays. By the time you have some new process that generates more traffic,
okay,
and it goes on a 3rd CPU, you set up the 3rd essay.
So given that, security gateway works with 24 cores, I'd like to avoid this 24 exchange to set up a gateway.
At that point, you're doing 40 or 100 gig of
time.
traffic, right? So I'm not sure how that matters.
So can you take this to the list? Because I think this is a good discussion. It'd be worthwhile to continue it on the list. So with that, I think we're going to close the meeting for IETF 106. So thank you.
Yeah, in this one. Mostly because if you are creating lots of essays, you need to have so creditor 1 and 2. That's
not with this one.
No, you need that anyway, because if you have a system where you have lots of essays, and that's why if you have a Windows size, bigger Windows size, we actually focus on this. Okay. Because you can then create child messages at the same time,